Alright, we're back with problem 15. We got cut off last time by the video. We can only record 15 minutes. So let's go ahead and get started again. This problem here, number 15, is asking us to find the equation of the circle. First thing we need is we need to know the center. So that is -3, 4. And we have to take those coordinates. And what do we have to do with each of those, Ms. Varghese?
We have to put it into the formula.
Put it into the formula, and we need to flip the signs of both of those.
Exactly.
I could have asked a better question there. Okay, so x minus
No, y.
4. Oh, y minus 4. Thank you, Ms. Varghese. X plus 3, y minus 4. Both those have to be squared. And then we have to set that equal to the radius squared. So first that means we have to find the radius of this circle. So there are a couple ways you could do that. You could use distance formula, which you use in geometry, in order to find the length of this radius.
But do you remember that?
I never do. So what I like to do, and what Ms. Varghese likes to do a lot of the time, is we like to set up a right triangle. So as you can see, if I just take a line and I draw it straight down from here, run a line along the x-axis, and then connect it, I've formed a right triangle.
Or you can go the other way.
Yeah, you could do the other way as well. So we've created a right triangle, and the length of this line here is going to be the difference between our y coordinates. So this one is 4, this one's 0, so we know this line is 4 long, whereas this line goes from -3 to -6, so that's going to be 3 units long.
Because distance is always positive.
Distance is always positive, exactly. So it's a 3, 4, 5 triangle, which we've memorized because we know our special right triangles, but you could also use the Pythagorean theorem to figure out the length of the hypotenuse. So now that I have my hypotenuse, I'm going to write it down here just because I'm running out of room on my sheet of paper. It's going to be equal to 5 squared, and 5 squared is 25. So I'll just write it out one last time. X plus 3 squared plus y minus 4 squared equals 25. I messed up the squared sign. Squared. So let's just go ahead. You guys get it. And find that. Answer choice number 2. Alright, almost there, guys. Number 16. Ms. Varghese is creeping. Alright. A is equal to 3, B is equal to -2, and it's asking us the value of this expression right here. So let's go ahead. First thing we're going to do, just plug in for A and B. So we've got 3 to the -2 over
Use parentheses.
-2 to the -3 power.
You'll see why later.
Parentheses are very important. So whenever we see these negative exponents, it means that it's going to change the side that this thing that's raised to the exponent is on. So we've got to basically turn this equation upside down. So in order to get this -2 to be positive, we've got to move the 3 to the bottom. So I'm just going to rewrite this fraction, and I'm going to say this 3 to the +2 now is on the bottom. Now we've got -2 to the -3, and again I need to change the side of this thing in order to make the sign positive. So this is going to become -2 to the +3, and this is still in parentheses. This is 2. Okay, so now I've got to do -2 to the 3, so that's -2 times -2 times -2, and that is, I believe, -8. Yep, it's -2 times -2 times -2 is -8, and then 3 squared, I know right off the top of my head, is 9. So
Choice 3.
choice 3.
Last one. No, it's
Not
not.
the last one.
Almost.
We want it to be, but it's not quite. Alright, so now we've got x to the -2/5. This is a quick one, though, because we know how to do this. We've got a fractional exponent,
And
and
it's
it's -2. So
negative.
all kinds of fun. So first, let's get rid of the negative sign. So I've got to flip this fraction upside down, so I'm going to write it as 1 over x to the 2/5. And we're not done yet, because I don't see that there. So I've got to take this 2/5, and I've got to make it a radical, basically. So I'm going to write that as 1 over... So I see the 5 is down low, so that's going to be my radical. So it's going to be radical 5, and then I've got
Plant
x
root.
squared. The roots are going to be down below.
2 heirs exponent. There you go.
All right. Very good.
Wait,
and I didn't even
answer.
circle the answer. I got ahead of
Answer.
myself here.
Answer.
This is going to be answer choice sheet 4. All right. 18. Almost there. All right. Again, it's asking us to write an equation for this circle.
Wait. So let's go down to the bottom.
Shown below.
Oh, there's no answer choices.
This is one of those part 2 questions. Very
Part 2.
important. All right. So we know the center of the circle, so we can really quickly just do that. So we're going to do x, flip the sign, so x plus 5 squared plus y plus 8 No, sorry. I was looking at the wrong
-2.
coordinate. We're looking at the middle.
-2.
Excuse me. -2.
That's a minus sign, in case you can't figure that out.
Minus sign. Thank you, Ms.
No
Varghese.
problem.
Okay, and then we've got to, again, get the radius squared. So it's even easier to see the triangle like this, and we'll kind of write it the other way this time, because we've got the grids, right? So we can even count 1, 2, 3, right?
That's easy.
And this is 2.
Just make sure that your interval is going up by 1.
Yeah. Oh,
It is.
that's a good point. We should make sure. So the difference here between our x coordinates is is -5 and -8. So those are 3 apart. Great. So we've got 2 and 3.
Works.
Good. So we've got ourselves a right triangle. So here I haven't memorized a 2, 3, whatever right triangle. So let's use Pythagorean theorem. So I've got 2 squared plus 3 squared equals some hypotenuse squared. So I'll say c squared, or we could say r squared for radius.
Whatever you want.
Whatever you want. It's a variable. So I'm simplifying. 13 equals c squared. So c equals the square root of 13, because I had to square root both of these in order to get rid of this
But
squared sign.
in the formula, right,
Mhm.
we got to put the radius squared. So the square root of 13 squared is going to be,
13.
there you go.
Great. So be careful with that. Make sure to square it when you put it back into this formula here. So yeah, this is multiple choice. This is your final answer. I'm going to put a box around it so my teacher knows really clearly what my answer is.
It's a bad box.
It's a very bad box. I'm sorry.
Excuse us.
Excuse us for our poor box.
So this one does not have an
So
answer choice.
yeah, when you see this on your test, the answer choices are going to be whited out, because this is going to be a part 2 question for you.
We did that just for you guys.
Just for
letting
you.
know.
Because we care.
Because we love you.
It's true. Okay. So we've got heart rate in beats per minute of a jogger during a 4-minute interval. Whenever you see a problem like this, the question is typically going to be down below. So it says, what is the range of the jogger's heart rate? So our keyword here, Ms. Varghese, is
Range.
what?
Range.
Range.
Home on the range.
Home on the range.
Range.
So domain, of course, is going to be x. Range is going to be y. Up and down. Very nice. So we want to know the range of the jogger's heart rate. So we've got to find the smallest y. So the lowest value on the y-axis. And it looks like it's right
Boom.
here. So this is going to be y equals 60.
60.
And then this looks like the highest it gets, and that's y equals 110. So I'm just reading the graph, looking at the axis over there. So it looks like the range is going to be, we're going to have y in between the values of 60 and 110.
Why is it inclusive?
It is inclusive, Ms. Varghese. That's a very good question. I'm glad you asked. It's inclusive because these points here are shaded. You can see there's a solid black circles. If they were open, these would not be greater than or equal to signs. They would just be greater than and less than. So,
Great job.
good job, guys.
Hope
I
you
think
enjoyed
we
that.
actually made it through the entire key. See you next week.